Hello, my friends. To understand moment of inertia, let me go through the Newton's first law of motion. Newton's first law of motion states that if the body is at rest, then it will remain at rest. And if it is in motion, it will remain in motion until or unless it is acted upon by some external force. That means, what is the external force? What's its role? The role of external force is to change the state either of rest or of the uniform motion. Now, there is one problem. You just find it. If the body is having lesser mass or less mass, then you can change its state very easily. But if the body is having more mass, then it is somewhat difficult to change the state, maybe of rest, maybe of uniform motion. That means whatever the body giving the opposition to change itself is called inertia. Lesser mass opposes less to being a change. Okay, lesser mass opposes less to change. Bigger mass offers more resistance to change. That means that the opposition offered by the body is the measurement of a quantity which is called the inertia, right? Now we're coming, what is the moment of inertia, And before moment of inertia, one thing is more. You note it down, one thing more. The Newton's second law, that force is mass into acceleration. Acceleration equals to force over the mass, right? If the mass is less, then some force produces more acceleration in the body. But if the mass is more, it's a bigger mass, then the same force will produce a lesser acceleration. That is the concept of the inertia. Lesser inertia means a given force produces a more acceleration in that body. But if the body is having a big inertia, it gives a more opposition to change, then a given force will produce a lesser acceleration in that body. Now, exactly in the same way, we can explain the moment of inertia. Inertia plays a role in the linear motion, and rotational inertia, moment of inertia, plays the role in rotational motion. Now, if the body is at rest, okay, or if a body is orbiting along in a circular path, then you want to change the state either of the rest or of the uniform rotation. Then how you can? You can by applying a couple or the torque. Sometimes a lesser torque brings a change in the state, either of rest or of uniform rotation. Why? Because in that case, the body having less moment of inertia. And sometimes a more torque is required to bring a change in a state of the rest or of the uniform rotation. That means in that case, the body is having more moment of inertia. More moment of inertia means more torque is required, right? Now, the moment of inertia, this quantity is analogous to the inertia of the mass in linear motion. The moment of inertia is analogous to inertia. Moment of inertia plays a role in rotational motion. Inertia plays a role in linear motion. In linear motion, mass is the only quantity which relates to inertia. But in rotational motion, not only the mass, but distribution of mass about the axis of rotation. Like if this is the axis of rotation and body is orbiting like this, then moment of inertia depends upon how the mass of the body that is distributed, how the mass is distributed from the axis. Okay, like if I take the example of a disc and a rim, you know, let me take the example of a disc. Like this is a disc, and it is orbiting about let this is a disc. It is orbiting about this axis. Okay. Now then I consider the same mass, but hollow from inside. The total mass is distributed over the rim. Okay. The mass is the same. First of all, it is a disk. The mass is distributed. You find the moment of inertia. You find the rotation. Okay. You find the torque. How much torque is required to rotate it? And if it is rotating, how much torque is required to stop it? Now you consider the second case. It is the hollow from inside. And whatever the mass, this mass is then pasted over the rim. That means the mass is the same. Now you just notice how much torque is required to rotate it, and if it is rotating, how much torque is required to stop it? Is there will be different? Yes. Now in this case, the moment of inertia of it is high. Why high? Because the whole mass is on the rim, and moment of inertia is mr square. The whole mass is at the rim. So mass is away. More mass is away from the axis. That means rim is having more moment of inertia. If rim is having more moment of inertia, Newton's second law in linear motion, F equals to ma. The same analogous in a rotational motion. Instead of F, there is a torque. Instead of mass, there is a moment of inertia. Instead of A, there is angular acceleration. That is torque equals to I alpha. I equals to torque over alpha. So, if the moment of inertia is more, like in case of the rim, then somewhat larger torque is required to produce the rotation. But once the rotation is set, then larger retarding torque is required to stop it. There's a case of whenever the cat jumps from a height to the ground, how cat stretches its legs before jumping. Why? Cat increases its moment of inertia while jumping. Why? Because more moment of inertia, then less probability to rotate. Torque equals to I alpha. More moment of inertia, less probability to rotate. So the cat will safely land on the ground. Thus, that's a very good example. Again, okay. Now, if you're having the two eggs, one is a raw, other is the hard boiled, totally boiled. How you recognize which one is the raw and which one is the boiled? Very simple. Just giving a spin on the table. Give a spin. Giving spin to both. Find the difference. You know the raw egg will have somewhat more moment of inertia. You know why? Because the liquid inside, when you're giving a spin, the liquid inside, it tries to remain away from the center. When the mass tries to remain away from the center, its moment of inertia somewhat increases. So raw egg will have more moment of inertia instead of the totally boiled egg. So there will be a difference in the spinning. One, by giving the same torque, one will spin faster, one will spin more as compared to the other one, which will give a more, which will spin more faster. You know which one? Hard boiled, because they're having the lesser moment of inertia. Raw egg, because mass tries to remain away, more moment of inertia, so it will give a lesser rotation. It will have a lesser, spinning. So just by looking the spinning, you can differentiate which one is the totally boiled and which one is the raw. Okay. So I think you understand. More moment of inertia is beneficial for the stability, but lesser moment of inertia is good because giving a small torque, we can produce the rotation. So there is again plus points in lesser moment of inertia and some plus point in more moment of inertia. And moment of inertia, even it is moment of inertia is more, it is more important. If I ask you, what is the moment of inertia of the disk, and you are giving some answer, and that will be the wrong answer, because my question, I put a wrong question to you. I should put a question, what is the moment of inertia of the disk? About this axis, or about this axis, or about this axis, because moment of inertia depends upon the axis of rotation. Moment of inertia, no doubt, it is a constant quantity for a given body, but when you fix an axis, if I'm not taking the name of the axis and asking you the moment of inertia, then it doesn't make any sense. Doesn't make any sense. So moment of inertia of the body depends when you mention the axis of rotation, about which axis you are interested. Because then we find the mass of the body, how it's distributed about that axis. Okay, now a question for you. What do you think? Moment of inertia is a scalar quantity, is a vector quantity, or it is a tensor quantity? No doubt that moment of inertia is analogous to the inertia or the mass in linear motion. In linear motion, mass is a scalar quantity. But you think over it. If we are saying moment of inertia is analogous, so mass is scalar quantity, so moment of inertia should be scalar. But first of all, think, because moment of inertia depends upon the axis of rotation. But there are many axes about which the body can rotate. Is having many moment of inertias, a body having many different moment of inertias about the different axes, many different axes. So just think over it, then give me the solution. Okay, thank you.